One invisible pattern hides in 100 billion AI images your eye can never see. No color shift, no logo, no glitch. A hidden detector reads the mark. A human never cans. Here's why this stopped being a lab curiosity. On August 2, 2026, the EU AI Act's transparency rules took effect. They require companies that generate AI content to stamp their outputs with a mark a machine can read. Miss it and the fine reaches 15 million euros, or 3% of global annual turnover. The invisible mark is now the law. Start with text because it's the strangest case. Anthropic said Claude models released after August 2, 2026 watermark the text they generate. Here's the clever part. The mark isn't added by each app. It's baked into the model itself. So whether the words come from a chat window, an email draft, or a coding tool, the mark rides along automatically. One change, every product covered. No team has to remember to switch it on. Think of it like ink mixed into the paper at the mill, not stamped on later. That means coverage isn't a checklist anyone can forget. It's structural. But it raises an obvious question. If the words read completely normal to you and me, where exactly is the mark hiding? For images, the answer is simpler to picture. Google SynthID nudges the actual pixels. It shifts thousands of them by amounts too small for your eye to register. Arranged in a pattern a detector is built to find. The picture looks identical. The pattern is woven through it. And here's what makes it tough. Google says the mark holds up through cropping, filters, screenshots, even heavy compression. Screenshot it and the mark comes along for the ride. That survivability is the whole point. Metadata gets deleted on upload. A pattern living inside the pixels does not. The scale is the part that lands. Google says SynthID has now marked more than 100 billion images and videos, plus the equivalent of 60,000 years of audio. Other labs have adopted it too. So the image case works because there's a physical place to hide the mark. Which leaves the hard one. Text has no pixels at all. So where does that mark go? Text has no pixel to perturb. So the watermark can't live in how the words look. It lives in which words get chosen. Every time the model writes, it's picking the next word from a ranked list of options. Anthropic's method based on Google DeepMind's SynthID text quietly tilts those choices. When two words fit almost equally well, it leans toward the one that matches a secret pattern. Over a sentence you'd never notice. Over a few paragraphs, the bias adds up into a signal. Someone holding the secret key can measure it and say, with confidence, a machine wrote this. You reading it see nothing off. The prose still flows. Here's the catch that makes text different from images. The mark isn't in the letters you see. It's in the road not taken, the slightly less likely word the model kept skipping. Which sets up the real fight. Two totally different ways to prove where content came from are now competing. Now the two competing layers. The first is called C2PA. Picture a signed shipping label attached to a file, listing where it came from and every edit since. It's cryptographically signed so it can't be faked and it can prove origin. For actual files rather than raw text, Anthropic attaches this kind of provenance using the C2PA open standard, instead of touching the content itself. The second layer is the in-band watermark you just met, the pattern baked into the pixels or the word choices. One rides alongside the file. The other lives inside it. And C2PA is not some fringe idea. The coalition behind it has grown into a global community of more than 6,000 members across technology and media, aligning cameras, editing tools and platforms on one shared format. So we have a signed label on the outside and a hidden mark on the inside. Sounds like belt and suspenders. Except each one has a weakness that's almost the mirror image of the others. Here's where each layer breaks. The sign label is fragile in one specific way. Screenshot the file, re-encode it, or upload it to a social platform, and the label gets stripped off instantly. The picture survives. Its whole history vanishes. The in-band mark survives exactly that screenshot and repost cycle, because it's inside the content. But it has its own soft spot. Heavy editing, aggressive cropping, or paraphrasing can wear it down. And for text, there's an honest gap in the knowledge. It is not publicly settled how much rewriting it takes to erase a text watermark. A full rewrite likely kills it. Light edits likely don't. The exact line nobody has pinned down. So which do you trust? The answer companies are landing on is, don't choose. OpenAI is combining SynthID metadata with SynthID watermarking, so if the label gets stripped, the in-content mark still survives. It doubles the work, and a determined editor can still defeat both. It raises the bar. It doesn't lock the door. So here's the whole mechanism clicked together. An invisible mark now lives inside AI text, images, and audio. In images, it hides in the pixels. In text, it hides in the word choices. And a signed label can write alongside the file to prove its origin. But step back, because this is the part that actually matters. All of this proves one thing only, that a machine touched the content. It does not prove the content is true. A mark that says a machine wrote this is not the same as a mark that says this is false. Real photos can be labeled AI by accident. Lies can be typed by a human and carry no mark at all. The watermark is a provenance signal, nothing more. The genuinely hard problem was never the math of hiding a pattern. It's what platforms and courts decide to do with the signal once they have it. So the invisible mark is now stamped into AI text, images, and audio, backed by law and layered with a signed label. The technology is here. The open question is whether anyone actually reads the signal. Subscribe, and next we open the box on how a detector reads that hidden mark in the first place.